Hey boys and girls, I'm coming back to you with lesson 12 and I'm showing you a page out of the Ready book because I realized that in our last video I really only wanted to show you the area model, which is like this for 2-digit times 2-digit multiplying, and then I also wanted to show you the traditional way of multiplying. But now I want to show you another way. And if you remember last week in lesson 11, when we were multiplying 3 and 4-digit numbers by 1-digit numbers, I said that the partial product way was my least favorite. Well, there's a partial product way with 2-digit by 2-digit numbers too. And here's an example. And again, it's my least favorite, but it is one way that I want you to be familiar with. So let's go through the steps of this problem and see if this can make sense, okay? So the problem here is 28 times 16. Now, I'm going to take a minute and draw my turtle head. Oh, that is not very straight. And I see that I'm multiplying 28 times 6. The first step is to multiply 6 times 8. And in the normal way, we would multiply that and get 48, put our 8, carry our 4. But in partial products, we do no carrying. So we put 48 here. And just as a little reminder, that's because we multiplied 6 ones times 8 ones. Our next step is to multiply 6 times 2, but that's really 20. So 6 ones times 2 tens would be 120. Okay, now that's finished with our turtle head. And in the regular way, the standard way, we drop our turtle egg here, but in the partial product way, we don't, because we're going to just multiply as each place value is. All right, let me draw my other turtle head, see if this makes sense. All right, this go round, I want us to think that is really 110 times 8 ones. 110 times 8 ones gives us 80. And our final step would be 110 times 2 tens. That's really like 10 times 20. That gives us 200. So now we're given 4 partial products and we add them all up. This probably reminds you a lot of the way the area model works, because it gives us those same 4 partial products to add up. It's just a little easier to look at it in an area model than it is to look up and down. Okay, I want to show you one other thing. I saw this question and I thought, man, we should go over the fact that sometimes you're going to be given questions. No, this is 45 times 15, but it's not just simply, hey, go multiply. It's select. Is this a model that could represent 45 times 15? Is this, is this, is this, is this? And when you get a question like this, you've really got to stop and take one answer choice at a time. Now, letter A, let's look. Normally, when we draw an area model, we don't draw all these cubes or squares, but this does look just like the area model we've been learning. So I drew this. Here's the same problem. And I looked at it and I thought, yep, that's just what we would do. 10 times 40, 10 times 5, 5 times 40, and 5 times 5. So this would be a good choice. We would want to select that. That model represents 45 times 15. Now B is a number line. Now let's think, what is going on this number line? We're taking a jump of 15, another 15 jump, and another 15 jump. That would only work if our problem was 15 times 3, because that's 3 jumps. That's not our problem. Our problem is 45 times 15. They're trying to trick us by getting to 45 because that would be the answer. That's not what we're doing. So we do not want to select that choice. Now let's look at letters C and D. They look a lot alike. They're both 4 sets of parentheses. But I hope by now that you realize on letter C, we do not want that letter choice because that's taking all of the digits of the problem, but it's not really writing them in the right place value they are. So we don't want that. But D, look at what it's doing. It's doing just what we did in the area model, which, by the way, is probably a good idea if you're given a big multiple choice answer like this. It's probably a good idea to go solve that problem first before you make your choices. Now, here we did 10 times 40, and there is 10 times 40. We did 10 times 5. There's 10 times 5. Let's see if we have 5 times 40 and 5 times 5. 5 times 40 and 5 times 5. Okay, that model would work. It matches the area model just right. And last is another number line, but ooh, this number line might work. Now, another thing that helps me here is I've solved this problem. I know the answer should be 675. So, I'll look, and it ends on the right number. It's making a jump of 45 every time. And I counted these, and it is 15 jumps. So that would be a good choice. That is multiplying 45 15 times. I hope you're doing well with double-digit multiplying.